So the correct answer of this one is the 3.32 extra minus 34 meter. So you can use any of the unit at for your convenience, but it must be right. If you want to convert into nanometer, you can also calculate but multiply exponent 9 with this, and then you can get the value in the nanometer, centimeter, millimeter, so whatever you want to do, but it is more convenient to use a, if the value is so small, then you must use a smaller units. So use, you can represent in a good way to express the figure. So another, you just, again, you can watch the video and calculate. The answer is given over here, 7 exponent minus 11 meter. So in a similar way, you are just using the de Broglie equation and you are getting the wavelengths in any of the unit with if the speed or is given, and it depends on what is the value of that speed depending on the object is moving. Maybe it is a heavier or macro or the micro object. So this is our today lecture. Now we have learned about the wave-like properties of the particles and the particle-like properties of the wave. Now the important thing is here, now what is the position of the electron and what is the momentum, and can we easily or can we correctly locate actually the location of the electron, because electrons are moving in a circular path. Can we identify where is now the right now the electron is there, and if we can locate the position of the electron, can we also measure the velocity or the momentum? And this would be the angular momentum because it is moving in the circular path. So the mass will remain the constant, maybe the radius will remain the constant, but the velocity is important. So the nutshell of today's lecture, the objective is how can we locate, how can we position the electrons in a particular distance, and what would be the velocity of that electron. And or there is some sort of the uncertainty exists within the location or its momentum or its maybe the energy or maybe the time. So there are several factors we will discuss today. So the equation for the Heisenberg principle is very simple. This is the first have a look on this picture. I have explained a little bit. So let's suppose the electrons are moving in a circular path in a shell. Let's suppose it's a K shell, L shell, or M shell within the orbits. So what is happening over here? This is the original path, and this would be the expected path. But what is happening over here? The electron is hit by the incident photon, and because this photon is the wave, but this wave is having the particle-like property. That's why it is going to disturb the electrons moving in a circular path. And when it is hit, that means no, it is expected path is here. Circular path mein rehna chahiye, but now what is happening? This is the new path with some sort of the velocity. बिल्कुल वैसे जैसे ट्रांजिशन होती है, आप UV विजिबल करते हैं, now the electrons are being transited from the one shell to another shell. This is called the transition. Now the electrons were moving in a circular path, but you disturb the movement with the incident photons, and what is happening? The electrons are transit from lower state to the higher energy state, and that means now the movement of the electron is disturbed with the incident line. So this was the expected pathway, but with the interaction of the incident photon, now this is the new pathway for the movement of the electron, and we are considering this with new path, that means with having some velocity. So this is the importance for in this principle. Can we exactly measure the what is the velocity of this electron, or where is this electron right now. So these are the two things we will explore in today's lecture, with the position and with the distance travel, or what would be the momentum of the that electron. So he established a very simple equation. This is the delta x. X is the position or the distance. You can locate where is right now the electron is, and p is the momentum. Momentum is mass into velocity. So velocity is there. Velocity is there and position is there. That is the two things I am going to discuss over here. So what is happening? This delta is actually the uncertainty. So he identified that this the multiplication of the uncertainty in the position and the momentum will always be at least equal or greater than. At least this would be the factor, and this will remain constant. H is the Planck constant, 4 is the constant, pi is the constant, and this factor remains a constant. So if you want to measure exactly measure the position or the momentum, this is the position and this is the momentum, and this is the uncertainty. Delta is indicating here is the uncertainty. So dx will be the uncertainty in position, how much there is the uncertainty, and delta p will be the uncertainty in momentum. So these are the uncertainty. That means you are not going to, this would be the error, right? Uncertain means you are not exactly locating where is the position of this electron and what is the momentum of this electron. And momentum means know what is the velocity of this electron. So momentum में mass तो उसका constant रहेगा, electron mass will remain constant. So velocity and position, where is the electron right now and what is the velocity. So you can measure any one of maybe more precisely, but there should be more uncertainty in another factor here. Let's suppose कि अगर आपके पास जाए, this is the product of the uncertainty of the position and the momentum. As I have said, this at least will be equal to this or greater than this. ठीक, आगे हम इसकी एक्सरसाइज भी करते हैं. तो ये अगर आप इसको आप चाहते हैं कि पोजीशन उसकी लोकेट करें, राइट नो वेयर इज द इलेक्ट्रॉन, इसको आप करेक्टली मेजर करना चाह रहे हैं, देन the whole uncertainty will goes to the velocity of the electron, or you can say there should be more uncertainty in the momentum of the electron. And if you want to measure more precisely the momentum or the velocity, and then there will be more uncertainty in the position of the electron. You cannot easily locate where is right now the position of the electron. Position means in terms of the distance we will measure, like यहाँ पे मेरी अभी position यहाँ पे, आप बास्केटबॉल को मूव करते हैं, फुटबॉल को मूव करते हैं, कैन यू लोकेट द पोजीशन ऑफ दैट फुटबॉल? ऑफ कोर्स यू कैन लोकेट. सही है. तो दैट मींस देयर इज नेग्लिजिबल अनसर्टेनिटी इन द पोजीशन ऑफ द फुटबॉल. ठीक है. कैन यू मेजर द वेलोसिटी ऑफ द फुटबॉल ट्रैवलिंग? ऑफ कोर्स यू कैन मेजर. दैट मींस देयर इज नेग्लिजिबल अनसर्टेनिटी इन द वेलोसिटी ऑफ द फुटबॉल. Now we are going to, these are the macroscopic object. Now we are correlating this with the electron. Can you see the electron? No, we cannot see the electron. So that's why this phenomena, basically this principle is for the microscopic object like electrons, electron moving in a orbit. So now right now we will decide, we will further explore, can we locate the position? If you can locate the position, then what would be the velocity of that electron? Then more uncertainty will be in the velocity of electron. If you want to precisely measure the velocity of the electron or the momentum, then there will be the more uncertainty in the position of the electron. Clear? That's what now we are going to do. This is again the principle, the product of the uncertainty in the position and the momentum will at least equal to h over 4 pi. Now I am going to convert this into another very simple equation, because I need I measure the time. Now at what time is electron is there? Can I measure the time? and because it is moving, and what would be the kinetic energy of that electron. So now I am going to modify this Heisenberg principle to another equation, and the total product will remain the constant, that is the h over 4 pi. ये इसके अंदर कोई चेंजेस नहीं है. अब देखें, इसको अंडरस्टैंड करें. अगर कहीं पे आया तो दोबारा से आपसे कहते हैं घर जाके इसको वीडियो को दोबारा देखें, अपने नोट्स ये खुद बनाएं. ये यहाँ पे बैठे हुए इतने, यहाँ तो एक्सप्लेन मैंने कर दिया, एंड एवरीथिंग इज रिकॉर्डेड ओवर हियर. You can do the same exercise at home and write down your own steps with the same explanation what I have explained in the class. And this is very important. Otherwise, these are the principle or the equation which you are learning through your intermediate or the metric level. There is no change, and this will never change even in the PhD level, because this is a principle. It will remain the same, but the explanation or the outcome we are discussing, that would be different or depending on your level of study. ठीक है. अब आप देखें यहाँ इसको मैं थीम देखेंगे मैं कर क्या रहा हूँ. मैं इसको जो आपके पास पोजीशन, uncertainty in the position and uncertainty in the momentum, I am just going to convert into the uncertainty into energy and uncertainty into the time. dx delta x delta p को मैंने delta e और delta t में इसको convert करना. ठीक है. एंड ये प्रूव ये करना है कि बोथ आर द सेम थिंग्स. सही है. तो आप देखें इसी को मैं कोरिलेट करके आगे बढ़ रहा हूं. सो आई एम स्टार्टिंग विद द व्हाट इज द मोमेंटम हियर. आई एम यूजिंग दिस वन फर्स्ट. ठीक है. इसी इक्वेशन से मैं लेके आ रहा हूँ, कोई इसके अंदर कोई नया काम नहीं करना. ठीक है. तो दिस इज द अनसर्टेनिटी इन द मोमेंटम, एंड द मोमेंटम इज mass into velocity. So here in the second equation, I am going to multiply and divide with the time. And this equation and this equation is the same, because I am going to multiply and divide with the same factor. There is no change. ठीक है. वही आपके पास 2 से multiply करें, 2 से divide करें, the answer will be the same. There is no change. And why I am going to do? Because I have to convert this into the time. That's why I am using this factor to multiply and divide. Divide in the both sides. इधर करेंगे वो भी आपके पास आएगा मोमेंटम के साथ, जो नहीं करेंगे तो वैसे आपके पास. Okay. So what is this? Velocity over time is this is the acceleration, and this acceleration into mass is the force. Right? तो ये साथ लिखे गए. So velocity over time is the acceleration, and according to this formula, mass into acceleration is the force. Force is like if you apply a force on this, it has to travel with a specific time as much as I am going to apply this force on this object, and this is called the velocity. Sorry, force is the mass into velocity. So I am going to replace all this. This is the acceleration, this is the mass, and mass into acceleration is the force. So momentum is, this is another equation for the momentum. Momentum is mass into velocity, and you can say momentum is also force into time. And this is the same thing. And the second, in this equation, I am going to multiply the distance on the both sides. Why I am going to multiply the distance? Shabash. Exactly, Shabash. Because here, as I have said earlier, the original equation is this, and this is the position. This is the this is the position. This is the momentum. We have worked with the momentum in this equation, and what is left? The distance is left. Actually, position is the distance. कि कहाँ पे है अभी electron कहाँ पे है? You can locate. It is 1 kilometer apart, 0.1 nanometer apart. Where is right now the position of the electron? And the position is actually the distance. Where is, how much is the distance from one point to another point, and that is the position or the distance of the electron traveled. So that's why I'm going to multiply, and this is the same, momentum into distance or momentum into position or the distance. That's why I'm going to multiply with the distance. And now force into distance is the energy. That is called the energy, and time is coming from the equation. Clear hai ye baat? So force multiplied distance is called the energy. सो एनर्जी आप जब भी एनर्जी देते हैं आप क्या करेंगे, फोर्स अप्लाई करेंगे और ये जो है ट्रेवल करेंगे. इफ आई एम नॉट हैविंग अ सफिशिएंट एनर्जी, that means I am not going to move this object, so this is not going to travel. That means here the energy is insufficient, or I am not having the energy to move this object. So energy is actually the force applied, and the object is moving with a specific distance, and it depends how much force you are going to apply on a specific object. So what is this equation becomes, this is the same equation, and now this is the energy, this is the time. So this I have actually explained at the start. Now we are going to modify this uncertainties, and these are the two uncertainty in the position and the momentum. Actually these are the uncertainty in the energy and the time. So that is the same thing, these are equal to each other. So the equation right now, above equation becomes delta E, delta T will be equal or greater than h over 4 pi. So these two equations, the first one and the last one, this one are the similar. So that means there are four factors you can study by using the uncertainty principle. One is the position, another one is the momentum. This is the one, and the other one is the energy and its time. So you can measure the what is the energy. Energy is the kinetic energy of the electron, and you can also measure the time. Right now, what time is for a specific, it is going to travel from one point to another point. सही, तो दोनों इक्वेशन को जो है वो आप यूज कर सकते हैं. तो इसको सॉल्व नहीं करना, मैं आपको एक्सप्लेन कर रहा हूँ. ठीक है, अब यहाँ पे हम जो है इनको रिलेट करते हैं, लाइक इलेक्ट्रॉन इज मूविंग और द अदर मैक्रो ऑब्जेक्ट इज मूविंग, एंड देन व्हाट इज द अनसर्टेनिटी इन द मोमेंटम or in the position, and we will compare all these two uncertainty with each other. So the first one is the, like, how you are going to measure. This is the Bohr radius of hydrogen. That means only one electron is there, and the radius is this, and it is explained over here. The position of electron in this orbit is having accuracy of 1% of the radius. That means this is the uncertainty in the position of the electron. So distance traveled, how much distance it is, they have assumed that it is 1% of the radius. That means I'm going to multiply 1% with this distance. That will give you exactly the value of the uncertainty. ठीक है, ये ऐसा डायरेक्ट भी दे सकते हैं, आपको ये एज्यूम करके दिया हुआ है. दिस इज द वे टू कैलकुलेट, बट द मोस्ट इंपॉर्टेंट थिंग इज हियर. नो व्हाट इज द अनसर्टेनिटी इन द वेलोसिटी ऑफ दिस इलेक्ट्रॉन, एंड अनदर ऑब्जेक्ट इज a baseball with this one weight 0.15 kilogram or 150 gram weight, and it is moving with this with the thrown at this speed, and the momentum of this one is 6.7 kilogram meter per second. And now I'm going to measure the uncertainty in the position of the electron and the baseball. So first look at the first one, the position of the electron. As I have said earlier, this was the radius, and 1% mean 1 divided by 100. So you are just multiplying this factor, and the rest calculate this one, exponent minus 4 nanometer or minus 13 meter, and this is the uncertainty in the position of the electron. Okay? And you can use this equation to calculate the uncertainty in the momentum. ठीक है, तो क्या किया मैंने यहाँ पे, आपने अब ये निकालना है, तो डेल्टा एक्स जो है वो नीचे आके डिवाइड हो जाएगा. सही है, तो जस्ट यू आर नाउ यूजिंग the constant values to put over here. H is the 6.626 minus 34 4 pi, and this is the uncertainty in the position, and this you have already calculated over here. The important thing is you must use SI units. मीटर में आपने यूज करना है, दूसरे में यूनिट जो है यूज नहीं करना. And this will be the uncertainty in the momentum of the electron. And now what is the uncertainty in the velocity, because you are going to compare the velocity. And this is also very simple. Momentum is the mass into velocity. And the why I have not written over here, and this would be the uncertainty in the velocity. Where is the delta is mentioned? Delta is representing the uncertainty. So this is the uncertainty in the momentum, and this is the mass into velocity. Only delta is written with the velocity, not with the mass. What is the reason? Shower. Mass will remain, there is no uncertainty with the mass. When it is an electron, the mass will remain 9.1095 x minus 31. So there should not be any uncertainty in the mass. Only there may be uncertainty in the position or the velocity. And the momentum, actually, as I have said earlier, momentum mass will remain the constant, but there is the important thing is the uncertainty in the velocity of the electron, because there is no change in the mass of the electron. एक second बच्चों. Now again, this is the what you have calculated over here. Position, you are going to divide delta P with M, and delta P you have calculated, mass of electron is here, and this is the 1.1 exponent 8 meter per second. This is the uncertainty in the velocity of the electron. So what do you imagine with this number? The value, by considering this value, what do you say the uncertainty in the velocity of the electron? शाबाश, ये बहुत ज़्यादा value है. That means there is the much more uncertainty in the velocity. You cannot say no what is the velocity of the electron, and this is very similar to the velocity of the light. सही है, लाइट पास हो रही है, आप मेजर कर सकते हैं, ठीक है, तो इतनी ट्रेवल से हो रही है. दैट मीन दिस अनसर्टेनिटी इज टू मच विद द मूवमेंट ऑफ द इलेक्ट्रॉन. तो एटलीस्ट इतनी होगी, ये कम से कम है, सही है. It may be more than this, but according to this principle, at least there should be this uncertainty in the velocity of the electron. And it is written over here, you have no idea of the velocity of the electron. That is too much. You cannot say what is the velocity of this electron. Let's first compare with the other object. The second was the baseball, ठीक है, और उसमें आपको डायरेक्ट आपको दिया हुआ मोमेंटम उसका दिया हुआ है. देन देयर इज नो नीड फॉर द प्रीवियस कैलकुलेशन, डायरेक्ट आप यूज कर सकते हैं. एंड पोजीशन ऑफ in the similar way you can calculate, you can put the value 6.7 is the momentum is given in the data, and this is the uncertainty is of the baseball, uncertainty in the position of the baseball. And what is the, no, you can say this uncertainty is too small. That means this is negligible. That's why you can measure the position of the baseball जो है, as we theoretically explained before. आप move कर रहे हैं, baseball को move कर रहे हैं, you can say no, where is, how much distance it has traveled from right now from this position to the other position, and what is the velocity of the baseball. And this is the actually the practical application. These are the values, and this value is negligible as compared to the previous case. वहाँ पे बहुत ज़्यादा आपके पास है, यहाँ पे आपके पास जो है वो उसके मुकाबले में negligible है. So what is the output? So this principle is for the microscopic object like a traveling of the electron, and this is not for the macroscopic, because in the macroscopic object the uncertainty will be negligible. Clear? This is all about the एक से मैं इसको वीडियो को जरा